Well, thank you all for attending. Despite the rainy weather and the windy weather, you're still here, so that's lovely. So tonight is about server-driven UI. We actually have two speakers. So our first speaker will be Jaap, my colleague Jaap. He's been working at Q for almost 10 years now, I guess.
Yeah.
Working as a lead engineer on our one of our biggest projects, actually the mobile apps for HEMA. And the second speaker will be Laurens. He's been around for much longer than Jaap. He's probably one of our most experienced engineers and has done a lot of different projects on this topic. And the nice thing about tonight, I guess, is so at Q32 we are a project agency. So the nice thing about that is that we've been able to apply this concept at about 6, 7, 8 projects now. We've been able to start over from scratch again. We've been able to apply it for like our bigger clients, for startups, native apps, hybrid apps. So we have a ton of experience right now. And tonight we'll try to share these experience based on the two explicit use cases. But Jaap and Laurens will tell you about it. Each talk will probably take about 20-30 minutes, and then we'll move in a sort of discussion, panel discussion. So if you have a question because something is not clear or so you can't follow the speaker along, please raise your hands and just drop the question. If you have more like an insight or like a suggestion, please leave it for the end of the presentation so we can get actually your the thoughts of both speakers on your questions. I think that works better. So then, without any further ado, over to you, Jaap.
Thank you. All right, let's see if we can stick to the schedule. Right, so my talk is about SDUI, and it's a love story, and it took like a Shakespearean kind of structure to it. So it has 3 acts and an epilogue and I'm very well versed in Shakespeare, but I'm going to talk about the love that I feel for SDUI in this specific project that we've been working on. Maybe Laurens will talk about hate or resentment, stuff like that. We're going to see. Worry. So yeah, I already discussed the structure of my talk. The 3 acts will be about the things that I saw in the project, the things that we've been working on. And as Leonard said, I'm really curious also about your insights or thoughts. In the panel discussion at the end, I think that's a good place to discuss those. So, without further ado, let's get to it. And I'm gonna pose a statement and say that classic apps are a little bit like this character in Futurama. Is everyone familiar with this character? We really pamper our classic apps. They're like divas, and whatever they need, we do for them. If a new feature needs to be built, we all bow down to our app gods, and we say, okay, we're going to do this and this and this to make sure that we can build a nice user experience for the user. But is the user actually more important than the app? Well, maybe not. So this is like the classic app that we usually work on. And now we're going to transition to server-driven UI. Before we do that, maybe a show of hands who's familiar with server-driven UI. Yeah, a couple of people. A couple of people are not familiar, so I'll shortly introduce server-driven UI as well, because I'd say that server-driven UI is a little bit more like one of these machines, and you see them on the Dutch streets. I think the English word for it is a barrel organ, draaiorgel in Dutch. And what this machine does, and you can see the man here doing it, is you feed music through it, like some kind of sheet music through it, and then it'll play all these instruments. There's drums and there's all things in there. So for the people that are like, what the fuck is this? You can go to the Kalverstraat or any street in Amsterdam and see one of these in action. But the thing that's different here, in comparison to the classic app, is that we have this thingamajig. And what this does is it says, okay, bang the drum here, and then we have an organ there, and you need to play this note at this specific point in time. But the machine itself doesn't know the music. We feed it the music through here, and we can feed it all kinds of different kind of music, and it'll just play it for us. It has a limited set of instruments, so it maybe cannot play everything, but we can maybe add instruments to it if we'd like. But it's a machine that can do a lot of things. It has a really well-defined kind of API contract of the things that it can do, and that API contract is, well, like this, punch cards, and it'll just play it for us. So I said I was going to introduce server-driven UI a little bit. So for the people that are looking at this slide and hearing me talk, they're like, okay, I'm not really sure actually what then server-driven UI is. Server-driven UI can be explained by the server driving the UI. Well, that was nice, right? In a classic app, the server usually doesn't really know about the user interface. And I think we all think it's good engineering to make sure that the server doesn't need to know about the user interface, because the app has a user interface. We can have two, iOS and Android, or also include web, and then we have 3 user interfaces. And those are their own domains, and they know about presenting information to the user, and the server knows about databases and queries and grabbing information and then sending it off to some user interface with all kind of fancy things that we as like backend people don't care about. We just care about data and getting it across. And then have the apps decide, okay, Android, if you want to show it like this to the user, that's fine. iOS, if you want to show it to the user like this, that's also fine. You're in charge, I just provide you the data. With server-driven UI, we say, let's make that server interested or invested in the actual presentation to the user. So we're going to move some of the responsibilities that classically would be just in the app. Let's move that to the server and have the server decide, okay, what kind of components do I want to show on the screen. So in a little bit, I'll also show the version of server-driven UI that we chose in the HEMA project that I'm talking about. One thing we noticed is that this is a topic that you can discuss at length. At every project that you start, you can decide, okay, server-driven UI, yes, I'm going to do server-driven UI. What does that mean? And then for each group of 3 people, a different answer will come out. So that's also, I think, an interesting thing. So let me dive into the HEMA example, and we'll talk about the HEMA version of server-driven UI. And then I think in a little bit, if Laurens takes over, then he probably has examples that are different, and they made different decisions. So who's familiar with HEMA, the company? Most people. I put a screen recording of the app. So it's an e-commerce app. HEMA is a large Dutch retailer with stores, but also with e-commerce features. So I put this screen recording on here just to give you a little bit of context about what kind of features are in this app and what kind of like concepts do we have. So we're talking about e-commerce. So there's shopping. There we have a basket. We have a PDP, which is product detail page. We have loyalty things like vouchers that you can apply when you buy something. All kinds of things. And also you already see some screens in here, and you see some server-driven UI at work. So this is server-driven UI actually doing its thing. And you also see the basket here, and remember the basket because we're going to talk about it in a little bit. Right, so this was the prologue. Let's go to Act 1. Act 1 is laying the groundwork. So we started this project 4 years ago, I think. I wasn't there then at this project. I was doing something else. So I'm talking about other people making these decisions. But as all projects start, and I think you all recognize this, you start with a blank canvas, and you grab a pen, and you just start drawing all these kinds of things and all the insights that you had from your previous project and this blog post that you recently read, and you'll come up with a grand design, and it's usually different each time around, right? So for server-driven UI, as I said, there's a lot of different decisions that you can make, a lot of different outcomes you can have, and we can all call them server-driven UI, but it might mean different things. So let me introduce the HEMA version of SDUI. I will dive into this a little bit more in a bit, but for this HEMA project, our toolkit consists of a couple of things. We have a backend for frontend, the BFF, that's specifically built for the app, that caters to the app, and it doesn't care about other clients. It just says, okay, I know how to talk to iOS and Android apps and provide them with information that they can use to show a user interface. We have a schema or an API contract that the server knows and that the apps know, and that they've agreed upon to both support. So when the BFF says, I want you to show this component, then the apps, they need to comply. They need to show that component, you need to have that component. So this is the common language that expresses what our version of server-driven UI is. I will get back to that a little bit as well. Then what are the responsibilities of the app? Well, the app can draw components on a screen. Easy enough. Users can do things within the app that trigger actions, and actions can go back to our BFF that will do something with it. And our apps know how to handle all the things that are specifically related to the app and that the backend doesn't know about. So if we want to interact with a local API on iOS to trigger the phone, for example, yeah, we need some specific code on iOS to do that. We need some specific code on Android to do that. So both apps are responsible for interacting with those local APIs, but also to interact with external SDKs that we have in the app, like Firebase Analytics. So this is what the app knows, and I think the most important part of what it does is these two things: drawing components and triggering actions. It's you say, why take 4 years to build something like that if it's just 2 bullets? Then what the BFF knows how to do, it can talk to all kinds of services that are in the HEMA landscape, giving us information about products, giving us information about orders, giving us information about vouchers, for example. All that kind of stuff is the responsibility of the BFF. It talks with these services, and it knows how to convert that into a definition of a screen that it can then pass to the apps and that the apps can then show. I have an example of that in a bit. And the other way around, it can receive actions from the app and do something with it. So it can receive an action to add an item to the basket, for example, and it'll do the heavy lifting of communicating with some kind of backend service that knows about baskets and adding items to it, and then it can send back to the app something that relates to components. So that's like, I think, the high overview, and because every talk needs a diagram, this is the, the diagram version of it. I think this is quite similar to what you would do in a classic app as well, right? We have all kinds of services that are back there. We also have Contentful for some static content, but then we have an API that talks to the app. We don't talk to these services directly. Maybe in a classic app we don't have one single API, we have multiple APIs. Could be. But this, what's server-driven UI specific about this setup is the thing that goes over the line here between app and the backend. Because the backend doesn't just give data, it gives data in a way of okay, I want you to show it like this. And I'm going to skip a little bit in my slides because I first want to show you this. To make it very concrete, what that looks like in our HEMA server-driven UI setup. So this is a schematic of the structure that we use for sending data over that line I just pointed out. So the BFF can say return this kind of structure to the app, and then the app will know what to do with it. So we have a screen at the highest level, and the screen contains sections, and sections contain components, which is quite a, I think, easy to understand structure. And then what the apps do with this is they know, okay, for a banner that looks like one of these things here, it takes an image URL. I can take this image URL and show it. It takes some accessibility description, so we can present it to VoiceOver, for example. That's what I call a banner. And then maybe somewhere here might be a carousel, which contains different items, and the apps know, okay, I know how to display it. Maybe the designers integrated this in their design system. And they say, okay, a banner always behaves like this. It looks like this. These are the dimensions. There's a title above it. There's blah, blah, blah. All that kind of stuff we put in that screen definition. So that's what we send over the line. And it could also contain an action. For example, this banner component that we have, the towels are on sale. What should happen when we tap that banner? And then we have a range of different actions. For this specific one, we say we want to do a screen action, and the screen action opens the screen in iOS parlance, and say it pushes a new view controller to the stack with a screen, and we can pass a URL to that action, and the client will send that to the backend and say, okay, give me the content for this specific screen, for example. Like I said before, what kind of definition you keep for server-driven UI, there's many different ways of expressing these things. I was talking to one of you just before, and we're talking about using React syntax to express components, where we could build a large tree that defines a user interface. Well, that sounds really similar to server-driven UI, right? Which could be really more flexible than this setup that I just showed you here. So if we look at extreme flexibility on one side first, we could say we use something like React or React syntax, and we have text components, and we have image components, and we have maybe a table or something, and with those things we can build every structure, because we can use nested tables like we used to do back in the day with HTML maybe, and then we can express any user interface. And then we're basically building a web browser, and then we know that if we support that, then we can show any user interface that we think of, and that's great, right? Because then we're done. Well, that's very nice, but building a web browser is something that takes a little time. There's a couple of browsers or browser engines in there, and there's a reason that not everyone builds a browser engine, because the degrees of freedom that you have with saying, okay, everything can contain everything, and you can just do and send it to me, and I, as the app, will always, I promise, to always show that specific or exactly the way that it should be. Well, that's like a 10-year project on its own. So we need to scope that a little bit to make sure that we decrease those degrees of freedom, to make sure that the amount of work that we put in building our generic SDUI framework is manageable. And we can do that by saying, okay, we don't have these very hyper generic components, we have specific components, like the banner. The banner it has a specific meaning in the context of HEMA, and we know that, so we can do all kinds of assumptions and keep the implementation of what it means to show a banner quite simple. So going back to this slide and going to the other side of the continuum, we can also say, okay, we want to limit the flexibility as much as possible, and just have the server return, okay, I want you to show the home screen, and then have the apps know what the home screen should contain, and the backend just says, okay, for the title, I have a string, and maybe I have some URLs for banners, or but not much else. But then we're basically back at where we started. We have a very rigid app. The server doesn't really know a lot about the user interface, and so it cannot really influence the user interface to a large degree. So there we have an incentive to increase flexibility, and from this side we had an incentive to decrease flexibility. So we need to meet somewhere in the middle and say, okay, our schema, our setup, our definition of the way that this structure looks like needs to be flexible enough for like some definition of flexible that we feel we can create a lot of features with it, but it needs to be rigid enough to make sure that we don't invest 10 years in creating this generic framework, and also needing to test all different kind of combinations of what we can express with our schema. So, and this is a discussion that is something that we have with all SDUI projects that we start, and we sometimes end up with on different spots. So I think we've also been here in another project, and I think we tend to go this way rather than that way.
Yes.
So that's the groundwork, and to give you an idea, the HEMA SDUI setup contains 42 components. So I think we're done then. We should stop, which is still quite a lot, right? 42. So if we take the example from before, like taking the React syntax, and we have a text component in a table, then we have like 4 components, and then for some reason we have 10 times as many at HEMA. So there's no like good answer to what the amount should be, but this is for quite a large app, the amount of components that we have. So now that we have this groundwork, what does that allow us to do? And I've taken 2 examples of things that we use this SDUI framework that we have in our app for features that we build. And one of the things that we use SDUI for, and that I'm really happy about, hence why it's in this talk, is rapid prototyping. And this is a recent real life example, because I ask you to remember the baskets that you show, Winkelmandje, just now, because that's the version that we launched not too long ago, a couple months ago. Before that, we had a web view of the mobile website of HEMA, which showed the baskets. That had all kinds of issues and also all kinds of reasons why it was the way it was. But we figured we want all of our app is native, but not this specific screen that everyone that does buy something at HEMA in our app passes through. So we really want to make this a native thing. How can we do that? Well, it turns out that there's already in the HEMA services layer an API that we can use to ask what kind of items a user has in its basket. And it turns out that we have a component library consisting of 42 components. Well, it was less back then, but now it's 42. And maybe we can use some of those things. This is our server-driven UI style sheet. We have the server can send components to the client and the client will show it. Well, we also use that to create a list of all components that we do have with some specific types of data. So what you see here is the order product list item, it says, with a couple of variants. So maybe one with an image and one without an image, and with different prices and also with a sale price. So this is a component that we had lying around. And we had that lying around because we, at a previous point in time, had made an order overview of the previous orders that you did. And I think you can also already see where I'm going at, because we also had this component, the price line text component, which knows how to show a price in also a couple of different variants with sales prices and highlights and not. And we had a very generic component that we also have. I mean, we have specific components like this, but we also have generic components like buttons. It takes buttons and it shows it to the user. And if we combine those, we can create this screen. So our backend can use the API to grab all the items that a user has in its basket. It also knows how much sale is on those items and what the total price is. And it can show a button that will take us to the website, because we also have that already in there as well. And then maybe we can also already like build this experience and play around with it and see what works and what doesn't work and what the performance is and all kinds of stuff without actually doing like any iOS work. And so this is the prototype that we had during day one. With actual data, with the 42 or let's say 38 components that we had back then, with just doing server-side work of wiring up this new API that we had to our existing component library. And the only thing we did on the iOS side is say, okay, we introduce a new tab here, and that rather than going to opening the web view, it opens this specific SDUI screen. And then we took this and went to HEMA, to the stakeholders that needed to say, okay, this is something that we want. And then they were very enthusiastic about it. Also because we mentioned it the day before, yeah, we're going to try this. And then the next day we had this. And then we built it, and then it actually took 3 months to do all the finessing of making a really nice a component with a quantity control that has really nice animations and stuff like that. So, I mean, the effort then goes into polishing things, right? But it's now here and it wasn't before. And I think that's one of the powers of SDUI in this project. Another example of the things that we can do now that we have all the foundational work of the SDUI setup in the app is providing a personalized experience for the user. So in a classic app, if we want to do some personalization, or let's say A/B testing, because that's the example that we'll use in a little bit, we need to think up front, okay, what kind of variations of a specific screen do I want to have? And I need to create those, and I need to support those in the iOS and the Android apps, and I need to have some way of triggering them remotely. We said that in a classic app, the server doesn't care about the user interface, so we can't go to the server and say, okay, I need you to decide what kind of user interface I need to create, because the server's like, I just do data. You're the user interface part, I just do data. So we can set up a separate system for that. Use Firebase remote config together with A/B testing or something, and have that, and then make the apps responsible for being able to show specific variants, or to turn things around, or do whatever kind of things it wants to do to personalize the app experience. If we now go to our SDUI setup, we've said, okay, the server is responsible for the UI as well. I mean, together with the app, they work in tandem, but the server is involved, and it doesn't say that's not my responsibility. It says, okay, let me see what I can do, and that's the setup that we actually use here. And I've created this fictional example of this. So what you see here is an A/B testing setup that we can use to switch around two banners. I mean, it's a small A/B test. We don't know what's going to happen, but let's try. We can do it, right? So going back to the way we would do this in the classic app is to say, okay, we have a banner 1 position and a banner 2 position, and then have the apps check with Firebase, okay, what kind of group am I in? Am I in the A group or in the B group within this experiment? Okay, let me flip around these elements. But with our new setup, we can say, okay, we still connect to Firebase to have users be in either the A or the B group in the user test, but then the apps ignore that or do nothing really with it other than sending it back to Firebase Analytics. Okay, hi, I was in the A group, by the way. But the only thing it does, it provides that information through a header with all requests. In our case, that's the way we build it in HEMA. You could do that in all kinds of different cases. And it just provides, okay, I'm in this group. And then it's up to the BFF to do whatever it wants. And we've seen before that the BFF is totally in control of what do we show on the screen, in what order, with what kind of configuration. So we can do all of our logic of our A/B tests here in the BFF. And then it can decide, okay, if you're in the A group, I'm going to do this. Or we can do everything, all the degrees of freedom that we agreed upon in that continuum slide, like where we put a little mark. Everything that we decided that the server was going to be involved with, those are all the things that we then have at our disposal to make sure that we do something here. And this is something we're currently working on. We really want to start testing it with it because our app is in this mature state that we can really start improving on it. The SDUI setup that we have in this app will really allow us to do that. Yes?
Does that also mean you can do an A/B test without submitting an update to the App Store?
Good question. Because I now took the example of doing an A/B test, but you could also imagine other different kinds of personalization. Like, for example, we have specific banners for specific users. So if we say, okay, this user Jaap, and let's say there's a user Matthijs there, they have different sales options. Well, the server can know about it and just send new content. And that's in a classic app. If you want to do this kind of A/B testing experiment, we'd have to first build it into the app, ship that, go through app review and release, and then we only can target those users that have that version installed, because the old users don't know about what kind of things they need to change about when they're in a specific test group. And with this, we can target all apps out there. As long as they support those components that we have, then they can show them. So we don't need to go through app review to do that. Yes.
Cool. What happens when you update the schema?
You need to be very careful about updating the schema. We have a setup in this project that we have the app communicating to the server which version of the schema it supports. So we're up to version 22 now. And whenever we introduce new components, we have a runtime check in the server to see, okay, this app wants to get the definition of the home screen, for example. We want to show this new component, but it supports or uses API version 15. 3 of those components we don't have. Okay, we can't return those components. Maybe we have fallbacks. I mean, we can always, one of the first components that we built was a paragraph component. We can always show a bit of text. It's not going to be a nice fallback maybe, so we can decide, okay, we want to return nothing for this, and they just don't see it. or we have some kind of fallback.
Yeah.
But the important thing is for existing components to keep everything backwards compatible, so we can introduce new properties on those components. But if we want to do something that's really breaking, well, maybe we need to create a new component that's similar to that existing component, but then we have to. So that's something we need to be vigilant about. But
in our case, with the new version of the app took like 3 months in order for us to approve, for iOS to approve our product. Does that mean that we have to pretty much stay stuck in the legacy part per se and not create any kind of components until that issue gets resolved, or do we do any kind of other thing?
I'd say if you get stuck for 3 months, then that's a problem on its own.
So it's like an app payment issue. They requested that we need in-app purchases.
Yeah.
So to build that and then release that and then get approval, it took us like 3 months. So this means that if we were to adopt this earlier in the start of the project, we would be stuck in the same component list for like 3 months without any kind of updates. But the thing is, like, you can have all sorts of bigger problems with iOS, especially like how they control the App Store and whatnot. It's about. Does that mean that the whole project is going to be stuck inside a certain version of the schema until we get that approved?
Yeah.
We also built it so that the JSON decoder, it skips any component that doesn't know the type of. Like, it has, for example, a banner component. Well, I don't know that banner component. I'll just show nothing and move on to the next one. So it doesn't. We made it so that it doesn't break easily, at least. Yeah,
and so the old version of the app will tell that to the backend, like, okay, I'm on this old version of the schema that I know. So please don't give me anything that's not in that schema. And whether you can still provide a good user experience for that really depends on the kind of thing you're doing. For us, in practice, it's not something we need to worry about. We release new app versions, and with every new app version we might support 1 or 2 new components. It could be that a reviewer at Apple or Google doesn't really see that new component in action because the backend won't return it anywhere. But in practice we don't really get like rejections on that level. I mean, we also do payments, and we've had issues there in the past, so that's relatable. So I think the process around that is not really different from any like non-SDUI project.
My point is that usually like the web part of the project is usually the one that you experiment a lot on. So you basically do like 20, 30, 40 different experiments at any given time. And if the apps are lagging behind, especially in Android, because people don't update that often and Google doesn't enforce the update anyway. So if you have like a lot of users are actually stuck and doesn't actually update that application, it seems that you're going to miss out, like you can't really provide the optimal user experience for those users.
Maybe we should keep it for the panel discussion, this part.
Yeah, maybe one more thing to add, because at that point in time, like 3 months ago, we had an app version and an API version that we were happy with. So we can still provide that same user experience that we provided you 3 months ago. We can still do that today. We just can't use these new things. Well, we need to discuss whether that's acceptable or not. So let me close off. I named this talk a love story, and let me tell you why. So, as I said, we've been on this project for like 4 or 5 years. I wasn't there in the beginning, but I'm here now with the 42 components, and I'm really happy with the fundamentals that we have and this rich library of components that we do have. So I really feel in this project specifically that a lot of the time we used in the beginning was to sow the seeds of the things that we're now like harvesting or reaping. So the example of the basket that we created, that wouldn't have been possible a couple of years earlier. We could only do that because we had this mature server-driven UI set up. We had this mature component library that we used, and we were all really well versed on the way it worked. So we could be productive with it. And I think that's also the key part of why why and when this works is when you have a long timeline, so not one of months, but maybe of years, and you know that, okay, we're going to be committed on working this for quite a while, and we can really invest that time of sowing the seeds to use later on. If you have a project of a couple of months, you're going to be stuck with working on this basic infrastructure, and you forget to build the features that the user is actually interested in. So you need to have the balance, needs to be correct, right? So, and I'm not sure how many hours we spend on the basic infrastructure and how many hours we spend on building features, but the time of infrastructure is going to be considerable. So you need to have, the project needs to be large enough to account for that. It's interesting to see what kind of things we keep redoing each time we do a server-driven UI project. We had an intern this year that did some interviews at different projects and spoke to people to see, okay, what kind of things do you always do? And can we build like a generic framework so the next time we're going to do a server-driven UI project, we don't have to do that big of an investment, but we can use something that's already there. And what's really interesting there is the part that the continuum plays. Like, where do you want to be? Do you want to be hyper specific, or do you want to be really flexible? And what does that mean for a framework that needs to support that? So that's, I think, an ongoing thing within Q42. But yeah, I'm really happy about it here in this HEMA project. So that's it. That's my love for SDUI. Yes.
It sounded like a bottom-up movement, so you convinced the business to let you guys do this. But what were the key factors that convinced them?
So to build this specific feature that
to go for SDUI.
To go for SDUI. Well, I think Laurens was there in the very beginning. Do you know whether that was a discussion that we really involved a client with? Or is it something that we...
I think that that decision was made after me, so it's between us.
Yeah.
But I think it makes sense if you look at it from the broader perspective. You can make the business case for it.
Yeah, but it sounds so sober. A lot of business people will naturally push back. It's like, oh no, we're afraid that this is going to be a huge investment and then it's wasted effort, right? Mm-hmm. So there must be some, like for example, A/B testing, the flexibility with that, those kinds of factors that they were like really excited about.
Yeah. Mm-hmm. I mean, maybe Laurens has because you're going to talk about a different project, the way that it went there. I'm thinking with other projects, I mean, it's one of the many things that we talk about when we're going to work with a new client. So I think one of these other topics is always, where do we do hosting? Are we going to do AWS or GCP, or what kind of things you want there? What kind of stack? Maybe you have an opinion about that. Some clients don't really care about that. They just want a nice product, and they say, okay, you have a good story, and the price that you put on the paper is okay. I'm going to go with you. But it really depends on client per client basis of, okay, to what extent do they want to have influence on that?
Okay, yeah, maybe it's not the situation I'm used to, but you guys come with your expertise, and they are happily accepting your advice. And if you advise them to go for or give SDUI a shot, then they are more open to trying it. Mm-hmm. Because I've been working for enterprises, and any idea that you might have, as small as it is, it's going to get lots and lots of pushback from business, because they're afraid of any risk.
Right. Yeah, I think
so the situation is different.
I mean, as we go through that process as well when we're talking to prospective clients, and then sometimes there's another like a good match on that, and then we don't really. That could be a reason to not work with each other.
Apparently, HEMA like it, so it's good.
Yeah, I mean, and they're, I think, still happy with us.
Absolutely.
Any other questions or remarks? Yes.
So this new concept is only beneficial with mobile application, or could be also used for some web application?
It could be also used for other kinds of clients like web. So our focus was on two mobile apps, And this also comes up sometimes in discussions when we're talking about the way that we're going to progress the schema, for example. We need to have we have a lot of discussions. I mean, we're developers, so obviously. But sometimes that's something that comes up, and you need to make a decision. Okay, if we do this, then if at some future point somewhere down the line we want to support a different client, it might not make sense. And we try to be a bit pragmatic about it. To, if we can, keep open options. So if we do want to support web in the future, say, then we can do it. But we don't want to have like a 3-week discussion for something that might never happen. So if something is very complex to say we want to support web in the future, well, we're just going to focus on the apps because that's what we're supporting now. And then, yeah, if the future comes, then we'll get to it.
I'll talk a little bit about web server-driven UI as well.
Yeah, server-driven UI as a design pattern, it can be applied to anything like the web or a different UI paradigm, like a text-based UI. You could make a command line interface that uses SDUI. I think the sky's the limit there, right? Yeah.
Yes.
When an interaction happens, do you have any kind of metric of how much time does it take for an action to be triggered on the screen? Because you're making all sorts of connections to the backend, and then it transforms back the result. Mm-hmm. And so the latency, was it a match for you? Was it a problem for you?
It's a problem. I mean, there's more like chatter or chit chat between clients and server than there would be in a classic app. So that's something we're, I think, very cognizant about. Okay, we need to make sure that the user isn't affected by that, because this is a decision that we as developers made to increase developer happiness, to make sure that this app is more flexible, but that doesn't really serve the user. So if we do this, then we need to be make sure that we are kind to the user, and that's still a consideration when we're introducing new features. Of okay, how much back and forth can we have for the specific feature between app and server? And one thing we do is monitor the time that it takes for all the endpoints on our backend, and we have some benchmarks of okay, we want to make sure that we are below this line. That's could be then more important in this SDUI setup than it would be in a classic app. But when you have a slow external service, then that's a user experience issue always. So yeah. We're maybe more focused on it than usual, but it's still there. Yeah. Yeah. All right.
One last question. If for some reason, like AMS1 fails, what happens?
Maybe that's a good one to save for the panel, and then I can think about it also.
Cool. Thanks. I'll move this here. I'll stand a bit closer. So you have a quick moment to write down Jaap's details, but otherwise you can find them online. So I'm going to talk about SDUI and the worst thing that could happen to a team. I'm Laurens van den Oever. I'm one of the long-term people working here for a long time. I'm involved as an architect in many projects. Also in the first one that we did SDUI for, which is, I'll come back to that later. So after Jaap's love story, it's my turn to show you the other side of server-driven UI. So a couple of months ago, I got this Slack message from my colleague Anouk, and she was talking about a project that we did for a startup involving SDUI, and what she's saying, this was really one of the most bizarre projects I've ever been part of. SDUI works superb, so Betty and Rowan had almost nothing to do because everything already exists and can be clicked together, and now. So the context here is, we work for the startup, we were like an extension to their team, helped them build new features. They had some money and they asked us for a couple of weeks to add some more features. And Betty and Rowan started to build the features, and they were basically done. They had 3 weeks, they were done in a couple of days, and then they went like, okay, more features, please. Yeah, they didn't need more. They didn't have more features refined or ready to be built, so they were just ready. And then this happened. So this was a document from the internal development team at that startup, which I completely blanked out. To propose a change, remove the server-driven UI, get rid of it altogether. And we were like, what? We just had this week. There was still like waiting for more things to do, and in the meantime, this happened. And in the meanwhile, at another project, exactly the same thing happened. Like another startup where we laid the foundation for their app, also server-driven UI startup. A stack, and they were in the process of we were in the process of transferring the knowledge to their internal team. But also there, we were working a little bit side by side, struggling, rushing for features. There was a bit more integration in this team. The previous example, we were completely separated, working side by side. But here came a document from another developer at that company. Questioning the existence of the backend for frontend setup, like Jaap already mentioned, and it really meant the way we did server-driven UI, and the way that it connects the backend to the frontend tightly, and that it's very difficult to get anything done. We were like, what? So, but before to put those things in context and how we got there, I have to go back to the beginning. And 5 years ago, and the beginning was this, really. So this is a picture I was taken at the New York launch of Primephonic, classical music streaming service, the Spotify for classical music. And we were able to launch that in New York with our Prime Minister there. It's in front of the Lloyd Center, it's called Lincoln Center, sorry, the home of New York Philharmonic. Next to the Prime Minister are the founders of Primephonic, and then there's Brown Designer and myself launching their app. This was a startup that came to us asking, hey, we need to bring classical music streaming to the masses. Basically, we need Spotify for classical music, but Spotify has hundreds of developers, and we have a budget for 8, 10 maybe developers. And we need, to answer your question, iOS app, Android app, a tablet app, web player, and another platform that will be a surprise later on. So to build all that with a premium quality, so all of this you want to be native. It's Spotify competitor, so people are used to a certain quality level. So for us, we started this with saying, oh, it looks a little bit like React Native and React, and then you have sort of a shared stack, and we can do things there. But we started testing, and you need a lot of hardware integration anyway with the music streaming service, so we needed native developers anyway. So why not put all the logic that we can share across all these platforms to the server, which is a shared place to put the logic, and then we can do this more cheaply. Well, that worked out quite well, because this was the result. Apple acquired them a couple of years ago. We're still waiting for them to come out with the long-promised Apple Classical, which they would release, and we're still hoping that it will be pretty much our app, but then with applesauce on it. So within this project, this happened. They had a question, we have those platforms, what if we can add Sonos integration? So Sonos is the streaming speakers, and they have their own app that you can control, and from that app you can offer multiple streaming services. So Stuart, who I must say is a really brilliant developer, was tasked with adding this new platform. And after a week he said, it's done. But okay, proof of concept, so we know that we can do this. No, it's done, it's finished. And even search, like the whole app, all functionality, transferred to this new platform, 1 week, one developer. It's ridiculous. So then, how we get from there to back to this? Remove the server-driven UI. Well, where does this divide come from? So first, I have to go back to like app development, traditional, how we did it traditionally versus SDUI. So traditionally, Jaap talked about this as well. You have an API and you build two apps, basically iOS and Android. But then you want to reduce cost. So you have things like React Native, Flutter, similar, and then you build something. You can have smaller bits specific per platform. And then there's what we've done here, iOS, Android, maybe web, Sonos. I see missed an R here. And you put more of the logic to server-driven UI. So if I move the React Native one to the left, there's something in the middle. I need this. And this is the setup that we used in these two startups. So a front end with React Native and a server-driven UI API backend. And then you have sort of two solutions to a similar problem. A reason that, so we're here, both of these projects had this. The reason why we contemplated this is because there was always sort of, but we'll also do web type of thing in the air for both of them. And then of course you start building an app and it works well, and web is no longer a priority. Of course, there's I get back to other solutions when you get to this stack, but we looked at this hey, we need.
When you say both projects, you exclude Primephonic, I assume.
Both projects that yes.
Yeah.
So both projects, the two ones that wanted to remove SDUI. Yeah. Primephonic was a success in all regards. That went really well. Both the problematic projects were in the middle category. Now let's zoom on this and zoom in a little bit on this. So it makes a lot of sense that you have the same stack across the board. You have the server-driven UI. It's all TypeScript in our case. And you can basically separate the server part to the core logic, backend connecting to backend services, database, that kind of thing, and the server-driven UI thing, which describes how you build up the screens and where you go, the UI flows and things like that. So this bit is typically done there, but we basically move that part to the server. And one of the problems that we saw in both teams, that even though the server-driven bit is really similar to what you would do in React Native, describing what the screen looks like, developers were really reluctant to cross the barrier to the server. It's the same stack, same language, similar flow, similar things, but where our developers had no problem crossing the boundary and moving all over the place, we noticed that the developers at those two companies were really focused. I'm a React Native programmer. This is not React Native. I'm not crossing this chasm. I'm not going there, which makes it really hard to build a screen, because the screen description, it lives here. And while having that frustration, they were also thinking, what about Expo? If you come from the React Native world and you have this problem, a solution could be Expo. Why not just use Expo? Which is another solution that we could have picked, just not. We had the Primephonic success, so we thought this was a good solution.
What's Expo? I don't know it.
Good question. Expo is a way to basically ship the same logic to a React Native app without releasing a new app version. So it's like shipping code directly. In the other way, so it's not like you send screens, but you can release new code to your app, and you can also do that for web. So it solves a lot of things, but it also has pros and cons. So we could have done a comparison. And I think Anna knows much more about Expo than I do.
Yeah, Expo is actually a lot bigger than just updating apps. So Expo updates is just one package of Expo. So Expo is a large set of standards for developing apps in React Native.
Thanks. So that, given React Native, that would probably be a more logical route to go. Given we have a framework and we need to have something on the app, which is React Native, and then something on web. Anyway, so this is, we can conclude from these and it's two cases. Many React Native devs don't want to work on the server, at least in these two cases. We thought that it's very familiar, but still there was like an unexpected friction between the two areas. And there's Expo, which solves all these things as well, which maybe people are more familiar with, and given that group of developers would be a more logical solution for them. Another thing, the way of working was also a thing that stood out from both cases. Both cases that were not working. Like the role of the designer. So, if I look at a very simplified diagram of way of working, you have a designer who designs the app, then you have mobile developers building it, and then there's a backend developer building an API that provides the data for those apps. Luckily, there's communication between all of those, but typically it's sort of like starts with the design and front end and then back end, and the back end sort of builds APIs that are needed to build a screen in the middle, and it's sort of how it works. With server-driven UI, the server renders screens. So maybe you have front-end developers working on the server in that layer that talks about screens, but you also have the back-end developers doing that. In our project, typically we have back-end developers that are more thinking in terms of screens and user experience, so, and then front-end developers focusing more on the OS native type of interactions. But in order to be successful, you need to have back-end engineers talking to designers about screens, and designers need to think in designs and features in terms of the component library that you already have. Designers are moving towards design systems, but those design systems cannot stand on their own. You need to implement them in the server-driven UI component library. They need to be the same. If you don't have that, and you have a server-driven UI setup, but you're going to work like this, you have this nice and blue ocean, everything is possible design, then it goes to an app developer who sort of has to implement this complete deviation from what was previously there. And they go to they come there on the server and they have to build something new, and they have to, everything is new components, nothing can be reused. It's a very frustrating experience. This works much better. So I think part of the success of Primephonic, and I think in HEMA we do it also well, that the designers are very well connected with the development team. And in Primephonic, the designer was actually one of the Q32 people who can design, which is, typically we don't do that in-house, we're techies only, but there we made an exception. So really well connected. So, to recap, you require a different way of working. Design, front-end mobile developers and back-end working together. Of course, you want designers to design something that works well for the end user, but start with the things you already have. If you have a box of Lego bricks, use those first and try to see how far you get, and then really design the new bits on the bits that add value. And often we see designs that are just starting with a blank canvas and then design in the brand, okay, but not in the components that are previously there. And I think in most cases this actually also helps the end user, because your whole app becomes more consistent and familiar. For us, a big learning is that this way of working is an important part of knowledge transfer. It's implicit, we work this way, and then you transfer the tech knowledge and the stack. Hey, this is look at the Git and work with us in a couple of sprints and we develop new features, and then we can train you on the tech stack. But you also have to transfer the way of working itself and the way the designer is embedded in the team and all that. So, to recap, I think we have two things to consider. I think we have to be curious, really think if React Native and server-driven UI should be used together. In both cases, there were good reasons to use both those paradigms, but bringing them together in one project, they have a lot of overlap in value. So you have to really be on board and support it in order to get the value left for both the partial components. And if you transfer an SDUI stack, it's more than just lines of code. It's the way of working, but it's also the belief in what the system will bring for you and the performance. And one thing that I'll put in, because I'm actually a fan of server-driven UI, the Slack message that I started with, the fact that Betty and Rowan built all those features in a couple of days, that will be forgotten quite quickly. It was just a couple of days' work. Those features were not complex, apparently. They were, but it's just not visible. It's visible if you spend 3 months on something. Then it's visible and valuable. But the fact that you can do something in a couple of days is something that's really hard to feel as a value of a tech choice that you made in the past. And to really embed. So you have to really celebrate those successes as well in order to get people on the chairs for something like this. So thanks for listening to my rant. Like I say, I'm still a fan, and I think we should consider for our future projects. But we have to be very careful of these edge cases. Thanks.
Any questions already?
Yeah, you showed one of those documents, an RFC. It's like, is it a public document?
Request for change.
Yeah.
It's internal.
Oh, that's so formal.
Yes. Yes. It's very telling as well.
Okay.
Yeah. So it was, yeah. Our response to that was, okay, let's have a discussion. Let's bring people in the room and chat about this. No. We have the RFC. You can comment on the RFC. Which, yeah. I think, you need to work together in order to understand each other. And, yeah.
So if I may, Jaap, if you also join the stage. So I think we're a bit over time, but let's take a few minutes to discuss some topics.
It's a panel, we sit, right? That's, sit on bar stools.
Yeah. And I think to kick it off, I think it was two questions which were kind of related. I think you started asking about how to sell it to the business, and as well there was a question on how many releases end up doing. So actually I think the promise we often tell to our clients is about, like, okay, back in the day when we used to do only web development, it was like an easy job, right? So it was like we were developing for a single platform, we had total control of what we showed to the user, no need for backwards compatibility, but we just serve a single version, easy going. And then the mobile app world came along, we started introducing mobile apps, we had control over the user installing updates, we had to support multiple versions, etc., etc. And hence sort of the idea of SDUI was born. So often we tell our clients, like, okay, by employing SDUI, we can actually develop less complex code bases, and we can bypass the App Store reviews. We can just release new versions to the user much more easily. And then my question basically to you is are we actually able to deliver on this promise? Because if you start introducing a new component in every new feature you develop, or in every new A/B test you want to run, then you end up doing the releases anyway, like the question that was already asked. So are we actually able to deliver on this promise, you think?
So my talk was that I loved SDUI, but I'm going to be like realistic. So forget everything I said. I'm trying to think back of the last maybe year of working on this project and the things that we shipped. I think if you're going to do SDUI because you think that you'll build half of the features like newly in the components and you really bet on this time-saving part because we already have the things in place, so we don't have to build anything anymore. Then you're going to be disappointed because it's not that clear-cut. I mean, I think we in the team know our toolbox and hopefully know from those 42 components what we can do with them, and so when a new feature gets introduced and we're talking to the designers about them, especially exactly like Laurens said, then we're going to have the discussion. Okay, where can we use things that we already have? But in the end, we want to provide a good user experience. So if that means building a new component which works better for the situation, then we're going to do that, and then we're going to go through that release process. So for the HEMA project, we're still in a release cycle where we're going towards a release cycle. Ben and Karsten are really pushing for that to actually keep releasing new app versions every 2 weeks. And those might not necessarily introduce new components, but there are still two platforms that we have large code bases with, and it would be naive to think that we could put release a final version of the app and be done with it. So we're still releasing in like that cadence of every 2 weeks or 3 weeks. So yeah, and it fits in that. So it's not a problem for me, but yeah, I'm not going to skip it altogether now.
I think that depends largely on the maturity of the project that you're in, because in the HEMA we're like nearing functional completion of everything that needs to be done. So
don't tell HEMA.
And then you move on to optimization and a more visionary. Okay, what does this app needs to be, rather than just covering all functionality that people expect. And then you can start adding new features and playing with things and moving things around. And you get to more examples where you can do things without a release. And from the Primephonic example, where we did reach the maturity, where we that level of maturity, we still did not have many new feature releases, but we did do things like the favorites feature, where you could favorite albums and tracks, and that you have a list of the things that are your favorites. You could build the first version of that without an app release, the entire feature. So adding a little pop-up. We had a slide in the menu where we could have the add to favorites. We could add a new screen with a list of favorites, or we had a place for that. The entire feature and playing those favorites was something that could be done without an app release. And it's not so much that saves time, because in the end we did add a nice heart icon and things like that. But we could then user test this and see how it works, and even just test it yourself, and using the feature in its preliminary form really helped shape the final feature to build that when we did add the real components. So I think the real frequency of release and skipping the app review is more nuanced than just time saving. Yeah.
Does that sort of answer the questions you had, or any follow-up questions based on these insights and nuances?
I've got a couple of questions. The first is, do you also ship navigation through the server side?
I think this is the hardest
you can have this one.
You can skip it as well if you don't want
No. Main navigation, no, but sub-navigation, yeah. So basically tab bar is something that's hard-coded into the app. And then within the tabs, where you move towards and the new screens is something that is controlled by the server.
Okay,
I think that's...
in the stack you sort of build it up with the server, but the stack itself is defined in the app.
Yeah, I think that's the pattern that we always end up going to, even though it's often a discussion point.
That touches on two other things that I also was wondering about. One was around skeleton UIs. Do you then update those at build time to reflect sort of the version you expect from the server? or how do you deal with an ever-changing interface?
Interesting one. We have in one project tried to do this to automatically generate those. So what I think the short answer is well, maybe you can have a more concrete answer, but one of the things that we did do in most of the server-driven UI setups is that if you link to a new screen, you already have a lot of the content from the previous screen. So you can load the header and all that already because you have that, and then you only have to load the content. So a lot of the skeleton is actual content that you already have. I think the HEMA app does that as well.
Yeah.
I'm not sure how you update the skeleton views.
Well, I think the example was also in my screen recording of the product detail page, which is like the hero of an e-commerce app. There we do the same because we come from a PLP. This is all e-commerce parlance, but the PLP is product lister page, and we already know the title of the product. We already know the price. We already know the main image maybe. So there we.
What if the components change, and therefore the initial view would be different?
Well, it's not necessarily on this level. It's not necessarily the component that we share, but just the information. So the BFF knows I'm going to render a product lister page, and each item of the product lister page to show that one, I need an image and an add to cart button, and maybe show some reviews, the amount of reviews. But then it also knows if you click that item, you're going to go to product detail page. I'm already going to provide in that response some information that you can then pass to that product detail page.
Okay, that sort of answers the final question I had. That was around pre-rendering. So you do pass in some context about potential next screens.
Yes.
I can elaborate on this a little bit because I built this. So for a navigation action, you can pass like a preview or loading screen essentially. If you don't do that, you get a generic spinner as a loader. If you pass that, sort of the server passes like a placeholder screen to that action, the app will display that while it's loading the actual content, and it will then merge the newly loaded content in there. So the placeholder, it is an entire screen definition, but it has some placeholder components, loading state components essentially.
Okay.
Yeah. And I think what's interesting here is that everything that we've shown, like in the diagrams of, is this high level overview of, okay, our BFF knows how to return screens and components, and it's real easy. But then when you get down to it, the user experience, if you want to really have a nice user experience and to minimize the amount of loading screens, then you're gonna have to do compromises with the purity of your schema and say, okay, we're gonna put all this additional data in there that is not really shown on the screen, but it might be shown at some later stage, and it does add to the amount of bytes that we send over the line. So I mean, it's not free. We can't really put everything in there. So we need to have a discussion about that. And I think that's where things get interesting. Also, is to what degree do you are you like a browser and you're going to say, okay, on every screen loads, I'm going to start with a white page and then just show whatever the backend returns. Well, that's not something that users expect. So we need to do better than that, and we need to accommodate for that in like an SDUI setup. That could be rigid. I mean, you're in control, but you're going to start with like basic principles. This is what we return. But then once you have that, you already start chipping in on it and breaking it.
What was interesting on the Primephonic case is that sometimes, so you have a long playlist, like an opera which has like 50 tracks, and every one of those tracks is like a detail view, or you have a long playlist with albums. So those one screen description could, like in extreme cases, be 1.5 MB, which is quite a lot of JSON. But stack was pretty fast, and one of the advantages was that if you clicked something, you immediately had your header, you were processing that, and by the time the next megabyte was loaded, it was already, you were only reading the bottom of the header. So having those two things work together was, it felt really fast, even though sometimes a lot of data was sent.
Yeah. And we
where do you work with caching? Do you cache on the device, or do you cache in the BFF? Do you cache data at all?
No caching in that app. It was all Elasticsearch.
Okay.
yeah, maybe for HEMA we do caching on device, also to make sure that if you are on a train and you're in the Schiphol tunnel and you start the app for the first time, you don't have, well, not necessarily the first time, because the first time we don't have anything in cache, but the second time, then it would be nice for us to be able to show you something rather than a spinning rookwurst, which is our generic spinner. It's a HEMA joke. So that there we keep that in cache, and then we have a mechanism that when we receive new data, that we transition into it nicely, so that it's nice for the user. But that's also an example of a trade-off where, yeah, the fact that you are really reliant on the server matters. Yeah.
Implementation question, I guess. Like, do you guys still have like specific screens, like a product detail screen, or is everything like a generic SDUI screen and it could be anything?
For the HEMA case, we do have some specific screens, still are specific headers, I should say, but we're moving away from that because this is also the trade-off between being generic and being specific. So if we want to keep things generic, then we need to have a lot of considerations that we don't that we can bypass if we say, okay, that there's this specific header thingy, and then we don't, all the other things, all the other pages don't need to know about this specific behavior. I think a good example is on the product detail page again, when you we have a buy button. I mean, it's e-commerce. When you scroll down, that buy button jumps to the header, and that's behavior that we have on that specific page. But we already know that we're probably not going to have that in any other place in the app. So then the trade-off becomes, okay, do we need to does every header in the app need to support a possible buy button jumping up there? Yes or no? And then we said no. So we made this thing specific. But it hurts because we don't want to. And actually now that I think our component library is maturing, we're seeing examples of where we decided to make things specific at the cost of being flexible, and that we're now seeing, okay, we can solve this in another way where we don't need to do that. But it's, yeah, we're trying to be not absolutist about it.
In the Primephonic case was actually quite easy. We had two screens, component screen, so that's for home screen, album detail, tracks, everything, and a list screen, which is something that you can sort and filter, and it's infinitely scrolling. So those two types of screens were so different from one another that it makes sense to have those two, and it gave nice flexibility. But it meant that you could not have like a carousel type component in a list, because it was not part of the list screen definition. Yeah. But it was fine for the case.
There's a question in the back.
Yeah, it's about database grind. Because you said like you don't use caching, how can you manage the cost effectively? Because running that might cost you like a lot.
So you mean hitting all endpoints all the time?
Yeah.
Well, actually, I think the setup for HEMA is we're in their AWS setup with all their other services. In general, we don't do any caching of screens, but we might do caching of some information that's expensive to gather. But that's not necessarily part of our SDUI setup. That's more like in the way that we communicate efficiently with those services, and SDUI is not really involved there. So I think there's no technical reason why we couldn't do more caching there, and I think you could consider caching the SDUI screen output, but you cannot make any assumptions about what user content you are caching. So we want to be flexible for user A's home screen could be different than user B home screen. You don't want to remove that feature that we so happily introduced with FDUI by saying, okay, it all needs to be the same because we want to do caching. So the same problem we have on web, right? So you have donut caching and stuff like that. You can do the whole shebang. For us, it's not a cost problem, and if we want to improve things, we can do so by caching things like behind or somewhere back in the setup.
And Primephonic case, well, I did say we don't have caching, but what we did do is basically, so you have like 3 million albums that you then, or tracks that you then connect to which composer is this and which work. So all those connections in data, they were all put in Elasticsearch. And each night we had a batch process that processed all those things. So all the data in the app was an Elasticsearch query, which you can do very efficiently. So you could say that made it not needed to cache anything.
On the caching part, is that on the iOS side, I believe, you do automatic caching of the HTTP headers that you send. So if this server wants you to cache something, you just send the cache headers and then you cache on the device.
Yeah. But caching often leads to bugs that are hard to fix. Rather not.
It seems to me that we started the web by doing everything on the server side, and then we moved away and created React and whatnot to basically solve that problem and move the logic back to the client. And now you're pushing that back.
You can have that cycle, you can bring it further back in history as well when you look at mainframes, and then we had all our PCs with a file share. And then we went to the web, and so it's a wave, always going back and forth.
Yeah. And I think Next is a good example that we have in React world, where we're like, it's good that our clients can render user interfaces, but what about SEO and stuff like that? So maybe we need our servers to be able to render some clients. And then I think this is a cycle that we keep on doing. Yeah, silver bullets are rare to come by.
Yep. So one more question from my side. So you both are sort of now backend guys doing mobile development. We actually have a few iOS developers with us tonight. So I'm curious. So maybe what are your feelings on SDUI from more like an iOS or Android development perspective?
So I feel like any pattern you have, for instance, reactive programming and other popular things, anything can be overused. You can over-apply it, and then for reactive programming, your entire app, it becomes one single reactive stream at one point, and you lost all overview of what's happening. And I want to be careful that we don't do the same thing with server-driven UI. We like it so much we apply it to everything, even though it might not always make sense for a certain feature to be server-driven. Yeah. I don't know. It's a trade-off, I think.
Anything to add?
Yeah, so I'm transitioning. Well, I did the Lighter project with Matthijs, which was more of like a classic app, I would say.
Diva.
Yes.
And now I'm at HEMA since mid-October, so like 3 months now. Time flies. And I think I've really enjoyed the stand-ups. Where it was a good example last week, where someone from HEMA, from I think the loyalty program, was like, yeah, we saw that we needed to add this button to increase conversion for like X amount of euros and then 2 minutes later, Jimmy came up and he's like, yeah, we already added that like 2 days ago. It's already live and whatever. So it was really fun to see how fast things could go. And since I joined, I think we only added half a component for like the flexible donations, I believe. So like everything was already there. Just we needed to tweak some components to make it work. And for the rest, we only did fixes, technical debt. But for the most part, everything was just server side and everything went really, really fast. So it's a pleasant experience, at least on my side.
Feel free. Yeah.
Okay, so when I came here, I was not familiar with SDUI, and I was trying to understand why is the reason, because this is a solution to a problem. So I was trying to understand what is the problems. And in my mind now there are 2 problems. Maybe you can clarify to me if this is the problem, which one? Is this concept made because the releases on mobile app are expensive, they take time, and so this is a way to bypass this step by just pushing code to the app and it's already up to date, trying to mimic what the browser do? Or it is something more general, it's even for the browsers, and where you ship data including some rendering. So you are making like a component that also understands how the data is being grabbed, so you can reuse those components without trying to implement the whole thing again.
Yeah. I think the main reason to choose for a server-driven UI is to share all the logic you have about the user flow in one location, that you only have to write that once. Because aside from the cost of writing it once in Swift and once in Kotlin, there's also communicating with the bigger team and getting everyone aligned and having the same user experience on both platforms. It's really difficult to get it right, and server-driven UI, one, allows us to write it once, and two, ensures that it's consistent across all platforms. I think that's the reason you choose for it. And then there's all the side. You don't need to have the releases. You can do A/B testing, the rapid prototyping. I think that's a typical case that you don't choose a stack so that we can do rapid prototyping. But when you have it, it really adds to the love for this way of working, which makes it something that we will sooner advise to our customers who happily often listen to us.
Yeah, so for me, I was also thinking about this while preparing this talk. Like, what do I like about it, and what is actually the drawback of the classic way of building apps? And one of the things I didn't say while describing like the classic app as a diva is the process. And you also touched on this a little bit. The way that we used to, and I'm exaggerating, build a new feature in an app is start with a blank canvas in all regards. So design could be one, but also development. So if there's a new screen or a new feature that we're working on, our work as app developers was that of grabbing a fresh piece of wood and just start chopping away. And we do that each time we build a new feature. And it's a fun thing to do, and it feels good, but it's not necessarily very efficient. And I think the thing that SDUI forces you to do is to apply some abstractions on, okay, this app of mine, there's got to be some things that are common to all of it. And if I then ratify that in an API contract and in a way of working, then I can also convince the designer that's the way that they should think about it. And then the development process then needs to accommodate this bit of SDUI, and that's also, I think, the core of what you were saying. If the SDUI setup is in charge, then if you don't like that, then it'll work against you. But I think we use it in our advantage to give some like guardrails of, okay, this is what we support in our app. This is what's easy to build, and this is what's difficult to build due to SDUI. And let's hope that we make the right things easy and the right things difficult. And then we force ourselves a little bit in one direction, and we can still build nice products, but we don't need to go back to that fresh piece of wood each time. But we can, apply some patterns to it.
Let's do 2 more questions. then we can just grab a drink and connect, and we still have plenty of time to ask great questions.
Yeah, for Laurens, I was just wondering, given the app portfolio of Q42, are there any apps where you would say that SDUI is not a good fit?
Yes, absolutely. So an app that's not really content driven, for instance. So we have apps that are basically controlling hardware. They talk Bluetooth and do something with it. There's no point in having a framework on the server that dictates the UI. We've had a game. That would not be a good match. Yeah, fundamentally, we have a discussion every time. So it's never clear cut that we should do this or not. If there's content involved, or if there's
it sounds like the importance of the offline experience, I think.
Well, that's Primephonic had an offline mode, and what we basically did was we sent like a sandboxed version. That's a music streaming app, so the music will not stream offline, so you have to download the music anyway. So you describe what you want to have offline, and when it was online, I'd make sure that it was synchronized on the music, but also the user interface. We had screen descriptions for everything that can touch the stuff that you have offline. So basically, it had an offline server-driven UI experience.
Yeah, that's a great use case, showing that it still fits there.
Yeah, and it worked. Yeah, so we have the whole description and all the screens just worked offline, but only in their limited environment of music that you downloaded.
Cool. Yeah. Any app that's like an editor, an image editor or a text editor wouldn't make sense to use SDUI. You could maybe put a fragment of SDUI in there for like the help section or the FAQ, but it's not worth the technical investment to set up the infrastructure for it. Yeah.
Final question.
Yeah, I was wondering how you communicate the additional constraints that you get for the design to the designer. And of course there's also new opportunities, but how do you get them on board and make very clear to them what they can and can't easily do?
We actually, just at the end of this day, we had a nice discussion with designers about some, for the HEMA project, updated design, and yeah, it wasn't necessarily an SDUI discussion, but it was a discussion that you always have with, okay, this thing that you dreamt of, how can we actually convert that into a working feature and stuff like that. As Laurens said, I think a lot of innovation is also happening in the way that designers work. So Figma is a whole different deal than slicing up PSDs when I was starting my career. So I think there's a wave of professionalization there, and I think designers are also starting to, or yeah, let me not speak for designers in the way they think, but what I see in the people that we work with often is that that's something that they're doing anyway, to go to design systems, and they're also working under time constraints, so they don't, I mean, sure, they also like starting with a blank canvas, but they might not have the time for it, and then it's for them also nicer to work with a design library that they have. And other than that, I think that all the technical parts of this aren't in place of people actually communicate with each other. So I think that's also the core of what you were saying, is a lot of this only works if you sit together and talk about things and then start coding or then start designing. So there's, yeah, you still need to keep doing that, or maybe even more.
Yeah, so I think if a designer is used to working in a design system, then it's about as easy to create the design as it is to create the actual screen, because we both have the components in place, and it's just a matter of dragging them in, right? So that is, it's a bit about is he or she acquainted to working in this way. And that's I guess where typically the discussion takes place. Anything to add on the final question from your side?
Oh, I think this was an excellent summary.
Cool. So many thanks for your attention. Feel free to grab another beer. Feel free to connect with Laurens. Feel free to connect with Jaap or any other one. If someone wants to start with applying SDUI, can they reach out, or where should they start?
You can send an email. We have several blog posts on our engineering blog that can help.
Airbnb also has a UI framework online, I believe.
Perfect.
I interacted with it. It's just it's hard.
Cool. So there's a few blog posts on our engineering blog, and you can of course reach out to Laurens or Jaap. We'd be happy to have the discussion. So thanks a lot.
Thank you.
Thank you.
Thank you.
Thanks.